Backyard Professor Math videos. I promised you I'd wear this t-shirt that I made, and I want to show it to you. That's kind of an up-close shot of it. I did several different types of fabrics on the piece. Well, that sun's shining on it, isn't it? I did several different kinds of fabrics. Let me back this camera up so that you can see this. I'm kind of proud of this. Why not? It's kind of fun, you know? It's the sun. Boy, the sun's right in the way, too. Let's see if I can block that out. Anyway, it's a great big picture of the sun. See his eyes and his nose and his mouth and all that. And I did that out of hundreds of pieces of fabric. And then what I did is I stitched. See if I can get a close-up. I stitched. You can see the different stitches. I stitched it all. There's a good close-up of his eye. There's his other eye. That's kind of a fun thing to do. Kind of a fun project. Now then, can we get on with the serious stuff like the math? Much more important than my silly sewing adventures. Anyway, I am the crazy backyard professor, Carry Shirts. I want to begin to graph linear equations. I think this is fun. I think it's so interesting to see how graphing, it's hard to exaggerate the significance of what this Cartesian coordinate system has done for us in mathematics. It has expanded our ability to understand not only the world better and math better, but how to use the mathematics to solve so much more than anybody could before even the 1600s. It's absolutely one of the most important, significant mathematical breakthroughs in all of the history of math. So, here's the question. How do we graph in one dimension? That's easy. That's the number line. You have 0, 1, 2, 3. -1, -2, -3. If you want to graph the number 2, you go to 0, because that's the origin. You know all of the positive numbers are to the right of 0, so you come over here, write 1, 2, and you mark a dot right there. That's how you graph the number 2. How do you graph the number -3? Well, you know the negative numbers go off to the left, and the further left they go, the smaller they get. Just like on the right, the numbers that go further right get larger. You start at 0, and you go -1, -2, -3. There's -3, and you dot the -3. I mean, really, that's all there is graphing in the one dimension. With the Cartesian coordinate system, we're going to graph in 2 dimensions, or we're going to graph on the plane. How do we do that? We have the same idea here. Whoop. I guess I better number it right, huh? 2, 3, 4, -1, -2, -3, -4. We just have a bunch of ticks on a line. We start at 0, and the number line goes out forever. Absolutely forever. They usually put arrows, not dots. Absolutely forever. The genius of the Cartesian coordinate system is we now add a perpendicular axis to the x-axis, and this we call the x-axis. We add a perpendicular axis up and down, and we call this the y-axis. Now it's interesting because we know to the right are all the positive numbers on the x-axis. We make the positive numbers on the y-axis above the x-axis. So there's 1, there's 2, there's 3, and there's 4, etc. And then we take all the numbers below, I won't mark 0. We take all the numbers below the x-axis, and these are negative numbers. -2, -3, -4. So that we have a Cartesian coordinate system of 2 axes perpendicular to each other, with the positive numbers to the right and above the x-axis, and the negative numbers to the left and below the x-axis. And this is how the Cartesian coordinate system, it's like being on a sheet Now it's like 2 dimensions. Now we can coordinate, or plot I should say, we can graph 2 coordinates. If we're given, say, a coordinate, I want to make sure I get all this information down. If we're given a coordinate of 2 and 3, the one thing that is so beautifully consistent and agreed upon at this point in time, hopefully it'll never change, I don't see how they can change it now, is whenever we're given a coordinate pair, the first number is always the x number, and the second number is always the y number. So we always know in all of the books, whether it's trig, algebra, calculus, it doesn't matter what book, the first coordinate number is x, the second coordinate number is y. So how do we use this information? What does this mean? What do we do? Well, we look at x, 2. This is the x coordinate. Starting from the origin, we count over 1, 2. So we're here at 2. Then we have a y coordinate of 3. So we've moved over to 2 on the x coordinate. We see the 3's are above the x-axis, so we go up 3. 1, 2, 3, and we plot our point, and we call that point, we always identify our points using the x number first, which is 2, 2 over on x, and 3, 3 up on y, so that point we call 2 and 3. And that's how we graph in this particular coordinate system. Now, what if we're asked to plot the coordinates, and they put parentheses around the coordinates? What if we're asked to plot the coordinates 4 and -3? Now that's not the same kind of coordinates. This is always x, this is always y. I'm going to encourage you to label these coordinates for now. You won't have to later on once you get used to it. But for right now, you're going to save yourself some grief, especially when we get into the linear equations and graphing them, by knowing which is which. X is 4, it's always calculated first. We go over here, 1, 2, 3, 4. Then we have y is -3. We know y positive goes here, so we're going to go below the x-axis from 4. x4, then we count down 1, 2, 3. And that's approximately where 4 and -3 are. Is about there. And you identify your point. So we have a +2 and a +3 up here. We have a +4 and a -3 down here. What if we're asked to plot the coordinate points of -1? Let's go -2. -2 and 3. Now here we had 2 and 3. We went over 2 and up 3. We just do the opposite here. -2, we're going to go to the left in negative territory, 2 units, and then we're going to go up 3 units, and there's where we plot that point. This point is -2 and 3. See how that works? Piece of cake. Now what if we're asked to plot a point of -4 and -4? Then we start at x. We always start at x. This is x, this is y. This first number x, this second number y. I can't repeat that too much. It'll save you a headache, I promise. I went through all kinds of silly balderdash because I did not keep this straight when I was in algebra. We go over -4 on x. Then we go down -4 with y, and we plot it and identify it. That's the point -4, -4. It's understood that every time you write a coordinate pair of points, the first number is always the x number and the second number is always the y number. On any number of coordinate points, x first, then y. X first, then y. So that's how we graph on a plane on the Cartesian coordinate system, more or less so. And I want to see, okay, and then the next thing I wanted to tell you, you'll notice that the Cartesian coordinate system has 4 areas, 4 quadrants. The first quadrant is the upper right. The second quadrant is the upper left. The third quadrant is the lower left. And the fourth quadrant, and they always put it in Roman numerals, that way you can feel like you're intellectual or something. And the fourth quadrant is the lower right. Now the reason this is important is because later on in calculus especially, we won't use this so much in algebra, but we definitely will use it in calculus and especially in trigonometry. We will use this idea, so I'm just introducing it to you now. It's not a big deal to worry about it. Just recognize there's 4 areas that the axes of x and y logically divide into. In this area, in number 1, quadrant number 1, give me door number 1, Bill, we have positive numbers and a positive number. If you have 2 and 1, there it is. If you have 4 and 2, there it is. All of the positive coordinate pairs are in quadrant number 1. It's a positive and a positive. In quadrant number 2, you have a negative x and a positive y. See that? Positive on the x and positive on the y, negative on the x, and when you come up, you're in positive y territory. In the third coordinate, you have a negative and a negative. You go over negative on x, and then you go down negative on y, so it's a negative and a negative. In the fourth coordinate, you come over positive on the x-axis. You always start on the x-axis. You come over positive, and then you go down negative into the y. So we have a positive in coordinate 1. We have a negative positive in coordinate 2. We have a negative in coordinate 3. And we have a positive negative in coordinate 4. And that's just more or less to give you an orientation, to give you an overall feel for what kinds of numbers are going to go where on this Cartesian coordinate system. It's really quite important to understand this. We're not going to use this a lot in algebra, but in trig, boy, in trig, you're going to memorize a whole bunch of stuff about this thing that is really spectacular cool later. Right now, we want to do linear equations. So, remembering that all coordinate pairs, when they're listed, are going to list the x number first and the y number second. The question is, what quadrant is 3 and negative 4? What quadrant would we put 3 and negative 4? The x number is 3, the y number is 4. So we know positive is to the right of the origin. The origin is right there at 0 and 0. We come over here 3, 1, 2, 3. And we've got a negative, so we come this way and we go down into negative y territory below the x. So it's going to be quadrant number 4 that a positive and a negative is going to be in. Right? You agree with me? Please do. What quadrant is negative 4 and negative 2 going to be in? Negative 4 is the x number. It's always listed first. We're going to go left of the origin on x, right? And you're going to come over here, however many 4 is, right to here. And then you're going to go to a negative 2, so you're going to drop below the x-axis. So you're in negative, which is this number here. So this is going to be quadrant number 3. What quadrant is 2 and 6 going to be in? X number listed first is positive, so we're going to go this way. We come over here 2. 6 is a positive number, so we know it's going to be above the x-axis. It's going to be way up here somewhere. It's in quadrant number 1, and that's the positive. And that's what we have, a positive 2 and a positive 6. What quadrant is negative 9 and positive 16 going to be in? We know a negative 9 is the x number. It's not a very good 9, is it? Negative 9 is the x number, and positive 16. We know negative starts here at the origin and it goes left, so we're going to come way the heck out here to negative 9, but we have a positive 16, so we come this way for negative x number and up above x for the positive y number. There's our negative and positive, our negative number and our positive. Does that help you keep that straight? We will do so many graphing and so many linear equations, this all will become second hat to you, I promise. It will be a piece of cake to know this. I'm just orienting you right now to this issue. Okay? Easy enough. Alright, now we've got the Cartesian coordinate system here with a bunch of letters interspersed throughout all of this area. What we're asked to do is identify the coordinates of the various letters. So what about letter A? What is the coordinates of the letter A? We look around here, there's F, C, B, D, G. A is right here. You always begin with X. You always begin with the X coordinate horizontally. You come over here, 1, 2, 3. Now it's going to go up above the x-axis on the y-axis, which is in positive territory. This is a positive 3, and then you go 1, 2, 3, 4. So A is going to be 3 and 4. Both of them are positive numbers. It's in coordinate number 1. So what are the coordinates of B? B is down here. So we start on the x-axis, we go over 1, 2, there it is on 2, and then we come down 1. So this B is going to be, we're going to the left on x, which is in negative territory, negative 2, and we're going down below x, which is negative in the y. So this is going to be negative 2 and negative 1. It's in this quadrant, and this is the third quadrant. Okay, what about C? Where are the coordinates of C? Where is C? C is way down here. So we begin on X. We always begin on X from the origin. We come over 1, 2, 3, 4, 5, 6, 5, because C is over this direction, so this is the direction. You're not going to go that direction to find C. You got to come this way. So you come over to 5. It's below you, so now you have to count below you. Negative 1, 2, 3, 4, 5. So C is going to be positive 5, the X number listed first, and negative 5 because we're going below the x-axis into negative y territory. So that's going to be negative 5. So C's coordinate is 5 and negative 5. What about D's coordinates? Where's D at? D is right here. We notice it's that side, so we go that way from the origin. Negative 1 on X. The X number is always listed first, and then we go up 1, 2. It's positive. It's above the x-axis, so we're going positive. Up is positive, down is negative, so it's going to be positive 2. So D is negative 1 and positive 2. Now what about the coordinates of E? What are the coordinates of E? E is right over here, right on the x-axis. So we count over 1, 2, 3, 4, 5, 6. The X number is always listed first. There's 6. Do we go up into positive Y territory? No. The dot is right on the axis. Do we go below in negative y territory? No. The dot is on the axis. There is no y here. There's just a d number 6 and y is 0. Right? Then we do f. What are the coordinates of f? We look around here. F is down here. We begin by counting. We start with the x number. We're on the origin. Are we going to go to the right and into positive x number territory? No, because this is on the y-axis. It's right there on the axis. So you're not going to count to the right, you'll miss it. Are you going to go left into negative x territory? No, because it's on the axis. So the g number here, starting at 0, is 0. I meant the x number. Is 0, and now we count down. So it's 0, and 1, 2, 3, 4, 5, 6. 0 and negative 6 for f. And it's not in any of the coordinates. It's not in any of the coordinates. It's on an axis, right? So then we want to ask, what about the coordinates of the letter G? G is right over here. We see it's to the right, so we start at 0, 1, 2, and then we go up into positive 1. So the x number for G is positive 2, then the y number is positive 1. So it's 2 and positive 1. So this kind of gets you a flavor for the coordinate system. It gives you a flavor of what parts are positive and positive, or negative and negative, or negative and positive, or else positive and negative. And we will use this so many times it becomes automatic. For right now, I want to take it step by step. I want to keep it simple and easy to understand. I'm going to go a little bit slow at first so that you can write it down as you're learning this stuff too. You better be writing this down. You're silly if you're not. Math can't be learned by just watching. You have to do it, right? And you can practice this on your own all you want to. Get some graph paper. Seriously, it's worth it. Get some graph paper. That helps you do these graphs so much better. So anyway, this is my beginning of teaching us how to graph with linear equations, and it really starts getting interesting here because we'll be able to see, which gives us greater knowledge, a bigger expansion of what our equations are doing and what the functions are doing and what they look like. And this is a great advance in mathematics, and we are privileged to be able to have this information. Aren't you glad you didn't live 200 BC? Yeah, that's right. They didn't have this. Anyway, that's what I wanted to share with you this one. I'll see you in the next video. Happy calculating, man. Have a great life. And hey, I will see you in the next video.